affair, and what I'm going to do is something very, very simple. So it does actually follow on from Dave's last slide. So we're in Europe, and we're interested in multi-party systems, and we're interested in what happens in multi-party legislatures, particularly those in which there is a very high level of party discipline. So parties are coming to trying to get things through legislatures while essentially being led by leaders who have a bundle of votes to deliver. So we're talking about weighted voting, essentially. And what I'm going to do is very simple, because it's really, I know there are probably people in this room, many people in this room, who think there's nothing that's model-free, but I'm going to claim that what I'm doing is model-free, or it's something that, a set of regularities that runs underneath every model, including the model that we've just seen here, and just derived from very simple arithmetic constraints on forming a legislature. So, because what I'm doing is very simple, indeed, I'm going to have to convince you really that it's interesting, and so my task here is, despite the fact it's very simple, it's nonetheless interesting. So that's what I'm going to try and do. I'm going to motivate it with an example here. Greece 2012, with 2 consecutive elections in a very high-stakes environment. Some thought at the time that the future of the euro was at stake as a result of these elections, because these were the elections that were held in the context of would Greece ratify the bailout deal that was being offered by the EU. Arguably, these are just 2 random draws, or 2 draws from a distribution of possible election results that could have been held. And the result, this result was a complete disaster. This result was success. Europe was saved. Europe was put at risk here. The financial markets were going crazy. Europe was saved by this election result. What's the difference between them? The difference between them is all contained in information about the relative sizes of the top 3 parties. So what I'm going to be talking to you about some inequalities that relate to the relative sizes of the top 3 parties that make a difference. And I'm only going to offer you conjectures about how they might make a difference, but that's what I'm going to do. The difference is, here the top 2 parties were not winning, and here the top 2 parties were winning. This party here, Syriza, was the anti-bailout party, and so we had here what I'm going to call a type D legislative system. It's characterised by the fact that the only 2-party winning coalition is a coalition between the top 2 parties. The coalition between the first and the third party is not winning. Syriza was implacably opposed to the bailout, refused to join any government that was going to endorse the bailout. And that was an inconvenient truth about the formation of this government. With a new draw on the election, Syriza actually increased substantially in its seat share, but lost its power, in a sense, to block the pro-bailout government, because the legislature had flipped into a new state where the first and the third party now contained a legislative majority. And so there's a separate draw from the election result, and the world was very different. So what I'm going to really argue is that there are different legislative worlds that exist in settings where we have 5 or more political parties that are well disciplined, and I'm not going to say anything about what they want or what they want to achieve, other than whatever it is they want to achieve is going to be achieved by getting it through the legislature. So I'm going to claim it's model-free, what I'm doing. I'm not going to say anything about utility functions for the most part. I'm just going to say you have to achieve what you want by getting it through the legislature. I'm going to say it transcends institutional structure, in the sense that institutions are going to make a difference. They're going to impose additional constraints on what's happening here, but they can't transcend the arithmetical constraints that have to be satisfied. And so we can build lots of fancy models on top of this. But these truths are going to be true even for all of those fancy models. Essentially, that a fancy model built on top of this is going to further constrain what can happen, but it can't transcend it. And this is part of a general project which has kind of always interested me, and frankly hasn't interested anyone else, which is to see what can we get without actually writing down a model from what we actually know about the situation, and a set of things that just we know to be true, that in a sense apply to any model that we would be trying to specify. So all I've done is write down a list of inequalities that relate to the sizes of the top three parties that classify legislatures into 5 types. And my claim is that these types differ from each other in interesting ways, and you have to be the judge of whether the ways in which they differ from each other are interesting or not. All I can do is advocate for that. One obvious type is where the largest party is greater than the winning criteria. Winning can be any number greater than 50%. There's only one point in the argument which I constrain winning to be a simple majority. So one is there's a winning party. If we set aside for the moment the possible endogeneity of the parties, so that if I'm in the opposition, I might try and split the winning party and entice people away from it, and I just assume that can't happen, then this is a fairly uninteresting case. And most of the time we're talking about this class of this set of cases here. So the next constraint I'm going to, first constraint and other constraint I'm going to impose in situations where the largest party is not winning, is that the first, I'm going to go flip to this end here, that the first and second largest parties are not winning. So this is what I'm going to call an open legislature or a type E legislature. So this is a class of legislatures in which the first and second largest parties are not winning, so there can be no two-party winning coalition. Every winning coalition has to have 3 parties. In fact, I'm going to show you that system has to have 5 parties for this condition to be satisfied. And it's a particular class of cases because it means that if you're on the outside of a winning coalition, which is going to have 3 parties, and you're going to try and break up a winning coalition by making an offer, it's always the case that you're going to have to make an offer to at least 2 parties. That you have to induce 2 parties to join you in order to get into the winning coalition. That's the only that's the only case. There's always a possible offer that you can make to one party in a winning coalition. So that's an interesting class of cases for that reason. And so within the remainder, we can divide them up according to the remaining set of inequalities. So this is an exclusive and exhaustive partition of the set of all possible legislatures. So we start from the other end. We can take a situation where there's what I call a strongly dominant party. So dominant parties come out of cooperative game theory. So a dominant party is where the largest party, as I define it here, can form a winning coalition with the second and third largest party, but the second and third largest party can't win on their own. So that party is in a position is in a more dominant position. And in fact, we can have a special case here, which is a system-dominant party, where the largest party can form a winning coalition with any other party, which is a kind of apex game. And so that's a kind of B-star special case of a dominant party. And that happens, therefore, if in a situation where the second and third largest party are not winning, but the first and third largest party are winning, and the first and second largest party are winning, but the second and third largest party are not. So that's a particular class of cases that we find ourselves in. On the other hand, the first and third largest party are winning, and the second and third largest party are winning. We're in what I call the top 3 system. I'll show you that. In fact, no other party can ever be pivotal in that situation. And so only the top 3 parties of the system are relevant to forming winning coalitions, absent any statement we might make about any utility function or anything like that. And then the residual set of cases arises here where the top 2 parties are winning, but the first and third largest party are losing, and so the only 2-party winning coalition is the first 2 parties. And so my claim is there are interesting things about that. So what I'm going to show you is, first of all, some interesting kind of accounting identities that highlight things that are true, certainly true about these different cases. And I'm going to show you some empirics that will show you that empirical political outcomes are very different in these different types of legislatures. So to say that this is why you should pay attention to this. So here are some things we know about type B. That's the system with a dominant party. Now these are nothing really theorems or anything like that. They're just like accounting identities. So if we have a strongly dominant largest party, the second and third largest party are a member of every winning coalition that excludes the first largest party. We said that's just certainly true. Only the first largest party belongs to every two-party winning coalition. No other party belongs to every two-party winning coalition. That's certainly true. And here's a piece of numerology here. This is just mysticism that I put in because I don't know what's important, why it's relevant, but it's interesting. Lots of W over 2 stuff comes out in this, and so one of the ways to know that if the first largest party is strongly dominant, the third largest party has to have a size that's less than half the winning threshold. These are just certainly things that are certainly true. So, in this top 3 system, which is kind of interesting, for me anyway, regardless of the number of parties, only the 3 largest parties can ever be pivotal. Because the second and third are winning, so the first and fourth can't be winning, and so it essentially follows from that. Every coalition, excluding 2 of the 3 largest parties, is losing. And in a sense, in the set of winning coalitions, we can substitute any of the 3 largest parties for each other in a winning coalition. So we can go straight to the Shapley value, to the Shapley-Shubik weights, to the minimum integer weights. They're all going to be the same for these parties. We don't have to do any fancy calculation. That's true even if we have 50 parties in the system. If the second and third largest parties are winning, the weights of all the other parties are 0, and the weights of the top 3 are equivalent. And there's another piece of mystical numerology there, which is that means that the second largest party has to be greater than W over 2. This is relevant, I think, for theorists because I observe quite a lot of models of multi-party competition start with the assumption of 3 parties. And the inconvenient truth about this is, of course, nowhere on this planet anyway, possibly on other planets, is there a 3-party system empirically observed. And so it's comforting to know that we do actually find top 3 systems, that is parties which there are only 3 parties that are pivotal in certain winning coalitions, even when there are 10, 20, 30 parties. So saying something about party systems which only 3 parties are pivotal is interesting, even though we don't observe systems with only 3 parties. Type D is not tremendously interesting. I'll pass over that quickly. It'll get you to dinner faster, to lunch faster. So things that we know about type E, that's the kind of open system where it's the kind of anything can happen system. It's totally unconstrained. As far as I'm saying, is that no 2-party coalition is winning. There are coalitions inside every winning coalition, so every single winning coalition contains at least 3 parties, then has the possibility of internal coalitions forming inside the parties. And if there is majority rule, this is the only circumstance in which I confine W to be a majority rule, I can show you that it's got to be the case that you only get this class of cases if n is greater than 5, the number of parties is greater than 5. And so if you want to model everything in a multi-party system and consider all possible cases, you have to have at least 5 parties in the model. Because if you don't know for certain that you've covered this class of cases. So those are the kind of generally interesting things. I said I wasn't going to talk at all about utility functions or any aspect, but I lied. I'm going to briefly talk about what happens if people are interested in policy. These are digressions in the paper. They're in an appendix because I didn't want to pollute the paper with anything to do with utility functions or anything like that. And so there are some interesting things that we can say about policy. So if we take a system dominant party, that's the apex gain, the party that can form a winning coalition with any other party. Then we know, for example, that we just take an arbitrary policy dimension which people might be interested in, that party is going to be pivotal, it's going to contain the median legislator on every single dimension, which is not one or the other extreme positions. So if we know we have that type of party system, we know we have a party that's in a kind of very powerful position as far as policy is concerned. It's not just about anything else. There's only in the extreme position is it not going to contain the median legislator. If we have a a system with a dominant party. That's not strongly dominant, so it's just the largest party can form a winning coalition with the second or third largest, but the second and third largest aren't winning on their own. Then, if the second and third largest are on opposite sides of the largest party, then we know that the largest party is pivotal. It contains the median legislature on any policy dimension whatsoever, for which this is true. It's flanked on either side by the second and third largest party. And in a top three system, so if we just see that inequality, second and third largest party are winning, we know that the pivotal party on every single issue dimension is going to be the most central of the top three. We don't need to know anything about any of the other parties, what the positions of any of the other parties whatsoever, so we can kind of just dispense with that. So this is kind of useful information for people who want to kind of model this, in my view. And as an aside, it occurred to me when I was doing that, this means that the Shapley value, and people continually finding interesting new things to do with the Shapley value, but one interesting new thing to do with the Shapley value is the fact that it's actually the probability that a party is pivotal on an arbitrary policy dimension, because the Shapley value is the probability you're pivotal on an arbitrary coalition ordering, and so the Shapley value is important to do, has to do with policy, as well as other things, because the probability you're pivotal on any arbitrary policy dimension. And that's because one of the things we often forget is that the probability that you're median, we often tend to focus on your position on a dimension if you're median, but it's actually much more, in most cases, it's much more to do with your size to have the median legislature than your position. Well, that was just a brief digression on policy. So now we move to empirics. So this is a great new data set for people who are interested in government formation in Western Europe. It's the European Representative Democracy data set. It's the Kari Strong, Wolfgang Muller data set. And it extends to all European countries, East and West, from 1945 to 2010. So I commend it to people, not least because it was put together by people who knew what they were doing, with all due respect to graduate students, not by graduate students working for small money during the summer vacation, but by country specialists who essentially put together and vetted the data. So my experience of working with these data is most of the data sets you get from people are absolutely riddled with mistakes when you actually check them, but this one is not riddled with mistakes, so that's a good one to use for that reason. So here's a way of kind of describing the inequalities. These are kind of slices through the cube of party 1 size, party 2 size, party 3 size cube. So this is the first largest party by the second largest party, this is the first by the third, and this is the second by the third. And so we can represent the boundary conditions for the boundary lines on the inequalities by lines that we draw here. And then we can plot all European post-war governments onto these spaces. And what we're interested in here is how close are governments to the boundary conditions. And we see that the areas of the space close to the boundary conditions between legislative types are quite densely populated. And what this tells us is that if we see each election as just a sort of draw from a distribution of possible election results, it's quite possible we'd have been on one side or the other of this. And so we'd have flipped from one type to the other, and this would have made the sort of difference I'm going to show you happens empirically. And so if all of the governments are way away from these boundary conditions, we would be saying, no, there's not much possibility of anything happening. If we sort of think of parties as endogenous, of course, the parties that are close to these boundary conditions, the party systems that are close to these boundary conditions, have political parties where there are huge incentives to try and lure legislators away to defect from one party to another, because you're going to flip the system from one party to another and change the structure of putting together a legislative majority. I can now see why the lights are going, because there's a light flickering failing here. So that's just where the governments are. So lots of governments are close to boundary conditions. So one of the things that we can do is we can just apply some artificial noise to the observed legislatures that we have. Ken Benoit is my co-author on this, and he favours taking the observed legislature and then basically drawing randomly from a multinomial distribution that's parameterized by the existing legislature, but you know, everyone has their own favourite sort of noise that they can add, so I don't think anything really follows from which sort of noise you use here. We're just going to shock the observed European legislatures and see how likely is it you flip from one type of legislature to another. And so we see these are the actual European legislatures. So if we have, you know, these ones with the system dominant party, it's quite likely that you're going to shock them into the type A system. That's a single party system. It's quite likely you'll shock them into themselves. It's quite likely you'll shock them into a system where there is just a dominant party, but it's not an apex game. Alternatively, if we have the type E systems, the very open systems where there are no winning two-party coalitions, the most likely thing is you shock the system into itself, and with some possibility you're going to shock it into somewhere else. So that's, you know, that's really just to get a sense. And so what we did, this is a part of the paper I would ditch if anybody disliked it, but it's there for the moment. Is that what we did was we ran some regressions on these shocked distributions to see, well, what sorts of things make a difference? What sorts of things flip a legislator from one state to another? And there are some interesting things that come out of here. So what we looked at was what will be the effect of a 1% increase in the seat share of the smallest party. This is not something that most people focus on in European results, the size of the smallest party. And it increases the odds of flipping a type B system to a type B system, which undermines the role of the biggest party. This is what happened in Greece, because the largest party became dominant as a result of a bit of a throw of the dice in Greece by 15%. And so it increases the probability of shifting a type C system into a type D system by 40%. So small shocks to the size of even the smallest party can have an effect on political outcomes. But the more interesting stuff on empirics is coming up now. So we look at three things. We're just looking at what are the differences between European legislatures on three things. One, bargaining delays. How long does it take to form a government? What is the number of days between the election and the investiture of the new government? Now we see we have to separate post-election governments from inter-election governments here because there are much lower bargaining delays for governments that fail in between elections. All sorts of reasons. There are various models of bargaining delays, but for my mind the most likely explanation of this is that most governments are brought down by somebody who has an idea of what the next government will be, and so there's a candidate government in place, whereas after an election people have to figure out there's a real shock here and people have to figure out what's going to go on. So overall the typical bargaining delay is 38 days for post-election governments, 30 days for pre-election governments. But as we get to more complicated systems, less constrained systems, every one of these things, every one as we go down here is less constrained in a sense, the bargaining delays increase very systematically. So it's just harder and takes longer to form a government. So this is actually just replicating existing models of empirical models of bargaining delays. You only really need to look at this model here, which has the country fixed effects in it. And we see that although the number of parties now doesn't make a difference, but we have a constructive vote of confidence for inter-election governments makes a difference, so we have to factor that out because in systems with a constructive vote of no confidence you can't form a government until you form another one, so bargaining delays are very low in that system. And Central and Eastern Europe is relevant, but the key thing is here, single party governments are the omitted category here. That systems with a strongly dominant largest party, all of the signs are negative, so there's a negative hazard rate on the bargaining delay, so bigger negative more negative numbers means longer delays. And the open system takes the longest to form governments, and basically as you increase the constraint, not perfectly, but a pretty strong pattern, we get more and more bargaining delays. And this is with country fixed effects. So this is within country. Here's the thing that is most striking, however. So David was talking about the ability to explain different types of government, and obviously we're interested, one of the very classical characterizations of government is whether they're minimum winning coalitions, one-party minority governments, minority coalitions, or surplus governments. And so it's a very standard thing to do to classify European governments in these terms, and it's a very standard conclusion everybody knows that minimum winning coalitions are a minority of the actual cases that form in real situations. And so we have to explain. The reason why we can't just focus on minimum winning coalitions is that only 194 of the 519 governments in this data set are in fact minimum winning coalitions. More of them are minority governments, and quite a lot of them are surplus majority governments. But the thing is, there is a very strong association between this classification of legislatures and the types of government that form. So if we focus here, for example, and if we think of a kind of traditional preoccupation with the way that people have modelled these things and say, well, a lot of models do tend to assume minimum winning coalitions. A lot of models of multi-party things do tend to start with three parties. Well, now we can see a top three system, three parties that actually have a non-zero minimum integer weight or a non-zero Shapley value. We see there's a very strong association between top three systems and minimum winning coalitions. So we see that the kind of intuition that if you have a three-party system, you tend to get minimum winning coalitions, does tend to be vindicated in the data. But once you move beyond the top three system, we see that if you have a dominant party, you're much more likely to get the minority coalition. In particular, very likely to get a one-party minority coalition when there's a system-dominant party. And when you have the kind of open system where there are no real constraints, you are very likely to get minority coalitions and, in particular, surplus majority governments. So there's a strong association between the type of government that forms and the type of legislature that you've got. So in a way, if you're modelling if you have a model that involves assuming minimum winning coalitions and having three parties, then you're okay, provided you're comfortable with the fact you're dealing with 59 out of 519 legislatures in the system that's going on. So, but it's okay within that set. So in a way, what I'm claiming is it may be useful to think of modelling within these types, because you may be able to get further than trying to model across all of the types simultaneously. And then we move on to government durations. And so these are just replicating some classic Cox proportional hazard models on the durations of governments, because this is relevant here because we're talking about governments that are in place. We're talking about how easy is it to break up an incumbent government. With a two-party coalition, if you're on the outside, you only have to seduce one party away. Whereas if you have a three-party coalition, it's a more complicated thing to do. So again, if we just do the classic duration models, where we have now, because we're only modelling, and we're not modelling single-party governments, and so we're dropping out the most unstable governments, which are the ones in the open systems. Again, we see that we are basically having a fairly systematic effect in terms of predicting, using these legislative types relative to the most unstable type of government, that we are actually predicting government durations as well. I'm not so interested in that because I think there's many more things that go on with government durations, but all I'm really trying to show you is that we have a set of very simple inequalities that we can write down that generate arguably different negotiation environments. I won't say bargaining environments because I know bargaining has a particular meaning to most of the people in this room, so I'll say negotiation environments for governments. And that these manifest in quite striking empirical regularities and differences between the different parties. And so that's exactly the same slide as the one I started with. This is to comfort you. I intended to get us from A to B, and I got us to B, and we're